Hi everybody, today I'm going to do a few application problems that use the law of sines. As a quick reminder, for a triangle with sides A, B, and C, and opposite sides capital A, capital B, and capital C, the law of sines says sine A over A is equal to sine B over B, which is equal to sine C over C. Our first problem says two radars 75 kilometers apart detect a plane. The angle of elevation from radar A is alpha equals 86.5 degrees. The angle of elevation from radar B is beta equals 84 degrees. How far is the plane from radar A? So I started by putting together a diagram. I have A on the left with alpha equals 86.5 degrees. I have B on the right with beta equals 84 degrees. And I have the distance from A to B being 75 kilometers. We're looking for the distance from A to the plane. Notice this time A is the location of the radar, it's not the length of the side. Let's call our missing length x. Before I apply the law of sines, I need to know the angle across from the 75 kilometers. Since we know all triangles have 180 degrees, we can subtract the 86.5 and the 84 from 180. This says that the missing angle is 9.5 degrees. Using the law of sines, I can say that the sine of 9.5 over 75 is going to be equal to, I need to look at the angle across from my missing side. I'm trying to figure out x. The angle across from it is 84. I want to use the sine of 84 over x. When I cross multiply, I have x sine of 9.5 is equal to 75 times the sine of 84. Isolating x, I get x is equal to 75 sine of 84 over the sine of 9.5. In my calculator, I go to the settings, I make sure I'm in degrees, then I type 75 sine of 84 divided by the sine of 9.5. This tells me my distance is 451.93 kilometers. Our second question says, how high is the plane from the ground? I put in my missing side of 451.93, and now I want to find the height of the plane. I can form a right triangle, which will now have a hypotenuse of 451.93 and a given angle of 86.5. I'm going to label the height as h, and then I want to think about my trig functions. I know alpha, and I know the hypotenuse. Because I'm looking for the opposite and I know the hypotenuse, I'm going to use the sine function. I'll have that the sine of 86.5 is equal to the opposite h over 451.93. I'm going to multiply by 451.93 times the sine of 86.5, which will give us the value of the height. 451.93 times the sine of 86.5 says our height is 451.09 kilometers. Our next problem says, to estimate the height of a mountain, two hikers find the angle of elevation from a point on the ground that is b equals 620 meters from the base of the mountain to be beta equals 49 degrees. Then they walk a distance of a equals 1700 meters straight back and find the angle of elevation to the top of the mountain to be alpha equals 31 degrees. We want to use the measurements to estimate the height of the mountain. Let's look at what we're trying to find. We want to know the height of the mountain h. Because this is a right triangle, we are going to use the value of alpha to help us find our solution. To find our solution, we're going to need to know c, the length of the hypotenuse. Let's write in everything we know. We know alpha is 31, beta is 49, the distance of A is 1700, and the distance B is 620. Because we know the value of beta, we can find its supplement, 180 minus 49, which is 131 degrees. Now that we have the 131 degrees, we can find our top angle by subtracting 180 minus 31 minus 131, which gives us 18 degrees. Having the value of 18 allows us to use the law of sines. Now we know the value of an angle and the corresponding length of the side. Now we can write the sine of 18 over 1700 is equal to the sine of 131 over the corresponding side c. Cross multiplying, I have that c times the sine of 18 is equal to 1700 times the sine of 131. Dividing by the sine of 18, I have c is 1700 times the sine of 131 over the sine of 18. Putting that in my calculator, I got 4,151.8955, which I'm going to write as 0.9, and this is in kilometers. Now that we have the value of the hypotenuse, we can find the height h. We'll take the sine of 31 degrees to be the height over 4,151.9. That says 4,151.9 times the sine of 31 is the height of our mountain, which is 2,138.39 kilometers. Notice we never use the value of 620 kilometers. Some problems will have extraneous information that might throw you off at first. So start with a plan, look for what you know, what you need to know, and then how the values are connected.